Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet, and in this we were doing LinkedList topic. Pattern was merge and sort, and today we'll see the next question, which is partition list, and it's very famous and interview asked one. So let's read the problem statement. It says we'll be given the head of the linked list, and we have and also x, value x, we have to partition it such that all nodes less than x come before than the nodes greater than or equal to x. So as you can see, the example number 1, 1, 4, 3, 2, and the x is 3. So 1 is smaller to 3, yes, so it will come first. Then 4, 4 is greater, let's keep it right side. Now 3, 3 is also greater than equal to it comes, right? So right side. 2, left side because it is smaller. Then 5, right side. Then 2, left side. Very simple, correct? But let's see the constraint. The constraint says the number of nodes will be 0 to 200. Because it says the number of nodes will be 0, so it is very important to add the base case in your code. Means if head is null, return null, correct? Now, as the number of, maximum number of nodes is just 200. So, iterating linearly will not cause any issue. Why? Because you know beyond 10 power 8, it's not safe. It might give you TLE, and for sure beyond 10 power 9 operations it will give. But anyhow, in linked list we don't do quadratic solutions, so we don't need to worry about. And also the value of node can go from -100 to 100. It is also safe. Why? Because we know in integer it can store values up to 10 power 9, and beyond that we have to save in long. So this is also safe, so we don't need to worry. So here is the problem statement. Here is the linked list we have been given, 1, 4, 3, 2, 5, 2. Okay, now think like it is a list, not linked list. Think like it is a list, means we will have 1, 4, 3, 2, 5, 2. Now, can I say, I will start iterating on this with a pointer and I will just check, ki, hey, are you greater than me or lesser than me? So 1 will say, hey, I am lesser than x, which is 3. It means it should come towards the left side. So I will take another list, I will put 1. Okay. Now again I will move my I ahead. Hey, what are you? So it will say, hey, I am 4. But here there are two ways. First is, in the first list put all the values which are lesser than x, and in the another list put all the values which are greater than equal to x. So in this way you will put 1, 2 and then 2, correct? And then here you will put 4, 3 and 5. Why? Maintaining the order, because 4 comes first, then 3, then 5. Now here are the two lists you have, then just concatenate it, means left list and say this is, suppose this is right list. So when you will concatenate 1, 2, 2 and 4, 3, 5 will come. Correct? Other way is iterate for one time and store it first. Okay? Store it first means 1, then 2, then 2. Means store only those values which are lesser than x in first iteration. Now again iterate for second time and now store all the values which are greater than or equal to x. Okay? So you will store 4, 3 and then 5. In both ways you will end up storing the values like lesser values towards left and higher values towards right. Okay? But in list, so it is very easy, correct? I just showed you. But how can we do in the linked list? So the very brute force approach is to read the values from the linked list, put in the list. Now apply that logic which we have just discussed. Okay, choose any of the methods. Let's choose first iterate and put the lesser values here, 1, 2, 2, and then iterate again and put the higher values here. Done. Now can I say my list is ready? Correct. Now what we have to do, just run again here taking current variable and now override all these values here, means 1, 2, 2, 4, 3, 5. Correct? And this is a linked list. You can say ki we have partitioned it, and this is correct. So what is the time complexity? First O of n to read the values and put inside this, further O of n to read the values and put in that order, correct? And then further O of n to override the values. So total O of 3n, which is linear only because n is 200. So anyhow it will be total 600, which is safer. But the thing is, here we have taken extra space complexity, and linked list is all about, can you give me the solution without taking extra space? And that's called in place linked list. But before doing that, let's write the code for this. So here is the code we have discussed. As the constraint says the node can be 0, so it is very important to add if head is null. Otherwise, we'll create the list, we'll start the current from the head, and one by one we will iterate and put all those values of current, means node value, which are lesser than x. So I will insert in the list. So can I say initially in the list we will have 1, 2, 2. That's it. Now again we will start our current from the head, and again we will iterate and put all the values in the list which are greater than equal to x. So after 1 to 2, correct? Now we have 4, so we will insert 4, then 3, then 5. That's it. And after this, see, there are two ways I showed you, right? So either run for 2 times or create 2 different lists. Both will take O of n space complexity only, okay, because here you are storing all the values in the list, and there you will take 2 lists with n by 2, n by 2. So total O of n space only. Okay, now once done, this is the list, we can say it's partitioned. Now we will again start our current and index 0, and we'll keep on iterating in the whole linked list until it becomes null, and we will just override the values by reading the partitioned values inside the node, and at the end we will just return the head, and that's it. It's very simple, right? So brute force is very simple because it is taking extra space complexity as well. So let's submit the code, and once done, yes, now we will see how can we write the code without using extra space. Now think, if you are not allowed to store these values anywhere, then how can we think? Means we have to play with the nodes itself. So if we will start with one pointer, suppose, okay, let's start with one pointer, let's name it current, okay. So we can check, hey, are you lesser than x? Yes, it is, okay. Then we have to separate it, na, for sure. Why? Because we need at least 2 pointers such that one pointer will take care of all the values which are lesser than x, and other pointer will take care of all the values which are greater than equal to x. So for sure one pointer cannot handle it, correct? So as there will be 2 pointers, one will be taking values of smaller than x and one higher. So let's name it smaller and larger nodes. Okay, these are the nodes name, remember that. Okay, now what we will do, we will iterate with the help of current, and we will check, hey, are you lesser than x? This will say yes, it is. So we will say connect yourself to next of small. So for this, smaller needs to be a node for sure. Node means a dummy node with value 0, correct? So yes, the idea is very clear. We will make node 0, okay, and we will call, let's say, small dummy. Another node with 0, let's say large dummy. Done. Now we'll ask, hey current, is your value lesser than x? It will say yes, means smaller, means we have to say, hey small dummy dot next connect current. Done. So we have to write key something like, if current dot value is less than x, then what we have to do? In small dummy dot next, we have to connect what? Can I say current? Yes. But wait, after connecting this, for sure we have to connect next time in this one next, correct? So if we are going to move this dummy dot next ahead, you know कि we will lose this linked list, correct? Means wherever the small dummy will be pointing to, we are only aware of that linked list. This so we will forget. Next time we will add 2, next time we will add 2, and suppose small dummy will point to this. Then how can we read the linked list from here? So to read the linked list from the head, it is very important to keep a node at that same point, and to iterate again make a new alias, correct? So what I am saying, small dummy and large dummy can be our dummy nodes, okay. Now to iterate in this, like here we have created a current node, here also we will create a small node and let's say large node, okay, because that is going to move. Okay, very good. So can I say, instead of small dummy dot next, we will write small dot next current will be connected. Done. Now in the else case, what will happen? Else means the value is greater than equal to x, means in that case we will say, hey large dot next, please connect current. But here what is this? Here current is here, we will say it's less, okay, connect. Now after connecting, don't you think here is small, right? So we have to move this small ahead, correct? Once connected, now this should be the small now, so that next time you will add to its next, correct? So after adding, it is very important to move your small at small dot next, similarly large at large dot next. Very good. Now once connected, we will say small will point to this node. Can I say? Yes. Now once connected, what we have to do? Don't you think we should move current also, so that next time we will compare this node? Yes. So no worries, either if case runs or else case runs. For sure, after coming outside, we have to move our current ahead. Current is equal to current dot next, correct? Yes. So now we'll say current will point to this. Now again we'll check, hey, are you lesser than x? It will say no. Then we will fall in the else condition. Large dot next, connect current. So in the large dot next, we will connect what? Can I say 4? Yes, we'll connect 4. Done. Now what will happen? Now again we will move our large from here to here, and also we'll move our current from here to, let's say, here, correct? Done. Now again in the next time we'll check, hey, are you less than x? No, I'm not. So again in the large dot next, we will connect 3. Again we will move large ahead and we will move current ahead. Again, now we'll check, hey, are you less than x? Yes. Then connect yourself in small dot next. So to small dot next, we will connect 2. Now we will move small ahead and we will move current ahead. Now again 5. In large dot next, we will connect 5. So now we will move large ahead. Now we will move current ahead. Again 2. In small dot next, again we will move small ahead and we will move current ahead. Now can I say current will become null? So do we need to stop here? So what will be the while condition? While condition will be, yes, ki hey, run this line of code until my current not equals to becomes null. And that's it. And after coming outside, wait, before returning, we will not return now. Why? Because see, you have small, you have large. This is a linked list you have 1 to 2 and this is a linked list you have 4, 3, 5. Okay. But don't you think to its next we need to connect? Come on. Yes. Large dummy or large dummy dot next? Yes. So what we will do after coming outside? Yes. We will write small dot next. I want to connect large dummy dot next. Done. So now what can I say? What can I say? This is small, right? So small dot next will connect to this, correct? So now if you will read from small dummy, it's like 0, 1, 2, 2, 4, 3, 5. But what should be the head? What do you think? 0 or 1? So what should we return? Head or small dummy dot next? Yes. So we will return small dummy dot next and done. You have written this code on your own, correct? So this is the optimized code. Now let's see what is the time complexity and what is the space complexity. First is how many time we have iterated on this. Can I say O of n? Because we have not repeated, we have not came back or restarted again. So O of n is the time complexity. Now space is O of n. Why? Because we are creating the linked list here. And in the previous code, it was exactly O of 2n. Although both are similar, only O of n, because the number of nodes are very small. So 200 space or 400 space does not matter a lot. But time complexity was 3n. Here it's exactly n. So anyhow, this is more optimized code. And guys, linked list is the only topic where linear solutions to linear solutions also, this is from brute force to optimize. Means making 2n to n is also the optimized. Making 2n space to n or O of 1 space is optimized. So that is why this is the optimized code. Here the space complexity is O of n and in the previous case it was 2n. Why? Because O of n for list and O of n for overriding, although you are overriding the same linked list. So sometimes we might feel ki, hey, we are not creating any extra space complexity for our use, but as we are returning that list, correct, so that will also get counted in our total space complexity. Okay, but for the interview this will be expected because this is the in place solution, means you have not stored in the list and applied that array logic, but here you actually applied the linked list logic. So let's write the code for this. So first we will create list node for small dummy, and that small dummy will start from new list node with value 0, correct. Now we will copy paste the same code for large dummy, correct, large dummy. Now we need two nodes. First one is small, that will help us to iterate basically, that will start from small dummy, and similarly we need list node with large, that will start from large dummy, and that's it, correct. So small and large has been started. Now we need a current pointer. Why? Because current pointer will actually iterate on the entire linked list, right? So we'll start this from head. Now until our current becomes null, we have to iterate here, correct. So what we have to do, first we will check if our current dot value is less than x, then we have to connect in small dot next what current, and we have to move small is equal to small dot next. Similarly, if it falls in else case, means it's greater than equal to, then we have to connect in large dot next. In large dot next, what we will connect? Current, and we will move our current ahead with large is equal to large dot next. Very simple. Now either if case run or else case, for sure current is going to move ahead with current is equal to current dot next. Now after coming outside, we can say we have two lists, correct. One is with small where we have 1 to 2, and second is large where we have 4, 3, 5, right. So we have to connect last node of small, where small is actually pointing to first node of this, and we don't have access for 4, so we will connect by large dummy dot next. Okay, so we have to write small dot next is equal to large dummy dot next. Now when we connected 5 to this, don't you think with 5 2 also got connected here, and we wanted till here. So it's very important to make large next as null. Did you understood this? Yes. So what we have to write, large dot next is equal to null. Then only we can say ki we have the entire correct linked list. And now we have to return head, but head though we don't have, so we will return small dummy dot next. Done. So now let's run the code. Okay, where I missed, oh my bad, list node. Okay, done. Now let's try to submit this. Okay, so let's discuss the time and space complexity here. We are iterating our current from here until last point, means we are not coming back again and we are restarting. So total O of n time complexity, correct. Now talking about space complexity, we have not created any new linked list. We have just connected, reconnected, means played with the same linked list. But anyhow, as we are returning this much linked list, that is going to take space. So that's why O of n space you can say ki it's taking. But any extra space complexity we are not taking from our side, correct. So that is why this is the optimized code. And in the previous approach, it was O of, if you remember, 2n space complexity. Why? Because first is when we are overwriting the same linked list, even though we are overwriting, but we are sending the entire linked list. And second was we were creating extra list to store our values, correct. So that was also one of the reasons that is not acceptable in the interview, because when we talk about linked list, it's always preferred to play with the nodes to solve the problem. So this is the acceptable code. So this was your Java solution. If you understood, here is your C++ solution if in case you are from C++ background, and here is your Python code if you are from Python background. So if you understood this problem very well, and if you can do this on your own with your proper notes, then for sure you are eligible to go in the sheet and mark the next question also from this sheet. And guys, if you have any doubt, any concern, please do reach out to me. You can mention in the comment, or you can reach out to me through social medias. I will attach the sheet link and my social media links below in the description. And if you are still watching till here, please do hit the like button and subscribe the channel, because it gives me more motivation to make more such wonderful videos for you all. And that's it. Let's meet in another video with some more interesting questions, topics and patterns. Till then, keep learning, take care of yourself and your family.